Okay, so we're going to find the relative maximum value of a function, f of x equals 4xy, subject to the constraint x plus y equals 4. Now this is a lengthy process, but if you take your time, it's not a very difficult process. So what we have to establish is what's called the Lagrange Formula. Okay? And what it says is that you take your original function in terms of multivariables x and y and subtract from that lambda times a function g in terms of x and y. And g of xy is your constraint function, but it's got to be equal to 0. Okay? So here we have a constraint x plus y equals 4. So to make that equal to 0, x plus y minus 4 would equal 0. So our constraint function is x plus y minus 4. Okay? So our Lagrange formula is f of xy, the original function, 4xy, minus lambda, it's a Greek letter, times all of this, x plus y minus 4. Okay, you don't need the equal 0 part. It's just the constraint that you get when you set it equal to 0. Okay, now I'm going to go ahead and clean this up by distributing my lambda. 4xy minus lambda x minus lambda y plus 4 lambda. Okay, now once you have this function, you take the first order partial derivative. So the first derivative with respect to all the different variables you see there. So using x as a variable, treating everything else as a constant. Well, if x is the variable, 4y is the coefficient, so there's 4y. If x is the variable, minus lambda is the coefficient, and then there's no x here, so that's a constant, the derivative is 0. No x here, that's a constant, the derivative is 0. So this is our first order partial derivative with respect to x. Now we'll do it with respect to y. And that's going to be treating y as a variable. 4x is our coefficient. There's no y here, so that's a constant. The derivative is 0. And then minus lambda here. And then the plus 4 lambda is also a constant. So here's your first order partial derivative with respect to y. And the last one we have to do is with respect to lambda. So treating lambda like it is a variable. So the derivative of that would be 0, but then we get minus x, because if lambda is the variable, minus x is the coefficient, minus y, and then plus 4. Okay, so now we've got to solve these equations like there are 3 equations, 3 unknowns. So we set them equal to 0. 4y minus lambda equals 0. 4x minus lambda equals 0. And minus x minus y plus 4 equals 0. Now, there are many ways to solve this, but what I see is that the first one, I'll just start with it. If I move the lambda to the other side, I get 4y equals lambda. So in this equation, instead of lambda, I can put 4x minus 4y equals 0. And I could go on and solve this for y and sub it in, or I could solve this by using the elimination method, which is what I want to do. And so I line up my variables here, my new equation that has an x and a y, and my constraint equation which had x and y. And if I multiply the first one by 4, so let's multiply this by 4, because I'll get a negative 4x, a negative 4y, a plus 16 equals 0. And now if I add them together, this is the addition method or elimination method, x was eliminated. And I get negative 8y plus 16 equals 0. Negative 8y is negative 16. That means y is 2. And there are several approaches you could have taken to solve this system, but you know, it doesn't mean that it's wrong. It could just be different. But I've got y equals 2, and now I've got to find x. And so I need to go back into this equation. Minus x minus y plus 4 equals 0. So I'm going to find the x from that. So I'll say minus x minus 2 plus 4 equals 0. That's minus x plus 2 equals 0. Minus x is minus 2, which means x is 2. Now, they're not always going to be the same. That's just a coincidence. So I have found that x is 2 and y is 2. So the maximum value of this is going to be 4 times 2 times 2. So that's going to be 16. So once you find the x and y, you just substitute it into the function, and then you'll find your maximum value.